My name is Myles Dixon. I've been working with InRhythm now for just about coming up here on 6 months. I've been working on a really exciting project with a company called Health First. I've been representing InRhythm as a development lead for Health First on a high visibility project there. But for today, I'd like to sort of shift gears into BabylonJS. So this is something I've used in the past for a couple of hackathons. It's a real fun tech stack, and excited to kind of give some more info on it to everyone tuning in. So without further ado, let's go ahead and get started. So what is BabylonJS? Very high level, it is a framework that is used for developing web-based 3D applications. Now, it's a fairly broad topic, and 3D applications does not mean just games, kind of as shown down here, this sort of Space Invaders looking game built with Babylon. You can also use it for 3D renders and sort of virtual experiences. Now, BabylonJS is based and written entirely in TypeScript, has support for JavaScript, as well as native application development. So what that means is with BabylonJS, you can write your code entirely in their framework and have it compiled down to an Android APK, a iOS app, or a web-based app. And being based out of TypeScript provides a lot of sort of advantages that I'll cover a little bit more in detail in the next slide. Additionally, BabylonJS is built to use W3C's new Web GPU standard, which is intended to be a sort of successor to WebGL. WebGL is a very popular web-based, essentially, wrapper around the OpenGL standard, and Web GPU is sort of an evolution of that standard, intended to take the functionalities of WebGL and OpenGL and move them sort of beyond. Essentially, Web GPU, rather than be a wrapper around an API, Web GPU is a direct way for the browser to communicate with a graphical processing unit in a computer, and affords Babylon additional functionality and features that the OpenGL and WebGL standards couldn't quite provide. One of the interesting things, and one of the things that I really liked about Babylon, is that their development team actually helped the W3C team to develop Web GPU. So not only do they implement it, they also sort of have a hand in creating it as well. And that gives them a real sort of deeper access to it. And that actually presents itself through both a sort of performance standpoint, as well as ease of use. Additionally, BabylonJS is a framework that's actually in use today by a lot of major companies. Microsoft has some applications that use it, as well as some non-technical companies such as Nike and Lowe's. Even Jeep has a implementation of BabylonJS on their sort of, like, they have like a Wrangler builder where you can go online to their website and say you want to, customize and build your perfect Jeep Wrangler. They actually have an interactive experience on their website that uses Babylon to provide a essentially virtual render of the Jeep as you're building it. Nike does the same thing with shoes, and Lowe's actually has a sort of virtual like room planner and room builder where they leverage Babylon for rendering that 3D space to build out your ideal project, whether that be a kitchen, a bathroom, whatever. Some other companies have actually leaned into Babylon as well for their WebXR implementation. WebXR is essentially virtual reality, or rather augmented reality even. So you can use Babylon to create a 3D scene or 3D, the 3D scene is 3D environment that you can then interact with using virtual reality headset and peripherals and controllers. I mentioned prior that I've actually leveraged BabylonJS in a hackathon. And what that actually was, the project we actually used it for, was to create a virtual banking branch where a client could log in to their online banking account and actually have a virtual face-to-face experience with essentially a virtual bank teller, where in VR, that client would find themselves in a banking branch looking around, they see other individuals there, and they actually have that face-to-face encounter, something that was sort of spawned out of, like, the idea kind of came from COVID and the pandemic, where people could no longer go to banking branches as easily. We thought, how can we bring the banking branch to our customers? And that was sort of where that idea came from. And BabylonJS made that a almost seamless feeling experience. Moving on from there, why would you want to use BabylonJS for your application? So as mentioned before, Babylon is natively written in TypeScript. So for any of you that have worked with a TypeScript-based application before, it offers really this unparalleled ability to kind of deep dive into the code and get an understanding for it. I find personally, when working with new stacks or new frameworks, that documentation only gets me so far. I find that I get a much deeper, much greater understanding of something if I can actually sort of peel back the layers and see how it works. And when you have an application that is from the ground up written in a strongly typed language such as TypeScript, you get a really deep understanding and a lot of really nice built-in almost self-documenting features as you kind of peel back those layers. So if you're working with Babylon in your IDE of choice, and you go, okay, what is this method doing? What is this class doing here? You can actually follow that definition, that type definition, back to the actual sort of source code, and you can see from the ground up where those methods or those classes come from. There are a lot of frameworks out there that support TypeScript, but are themselves written in JavaScript, and the problem with that is, while you can still kind of deep dive into the code source a little bit that way, you don't really get that same level of confidence that you're fully grasping what that framework is doing. Whereas with Babylon, given that it's documented well, typed well, and has that type safe binding there, that right away if you're trying to invoke a method improperly or call a property on a class that isn't supported. Additionally, BabylonJS has a sort of unique architecture in the world of in the world of web-based 3D renderers and engines. It has this real granular abstraction between all of its different classes and objects. When you're working with things like the scene or a camera or a light source, models, meshes, materials, all these things that have very sort of important definitions in the world of 3D application development. Some other frameworks kind of hodgepodge them together into a sort of amalgamation, but almost sort of calling back to that same point about TypeScript. Everything is strongly typed here. Everything is strongly abstracted from each other. And it gives you both a very that's the way to put it. Gives you a sort of a deeper insight into what each individual component does, but also in terms of performance allows you to really granularly pick out what parts of the framework you want to use to accomplish your given task or goal. Another big difference is that it's more of a game engine versus just a 3D renderer. So you get this almost, it's somewhere in between, I'd say, working with like a rendering software, just say like, your native HTML canvas, but not quite all the way into game engine territory with something like, say, Unity, if you're familiar with Unity or game development. Babylon has this kind of sit somewhere in the middle, where you have access to a lot of features and methods and sort of plugins that almost make you feel like you're just straight up developing a game in a game engine. And that kind of helps it with browser performance as well, because you have a lot sort of more, you have a more kind of sterile access to every render iteration that Babylon is doing. You can, asynchronously pause that rendering if you need to perform maybe some heavy compute operations, and then, restart that render once your network request or something has come back. And then, as mentioned before, WebGPU and WebXR. So at the time of this, at the time of use, BabylonJS is, from my research, the only framework utilizing WebGPU right now. As mentioned before, that comes with a lot of performance benefits. That comes with a deeper access to functionality and features that you wouldn't get with something like WebGL or OpenGL, or even it's almost at the level of Microsoft Vulkan and Apple Metal. Actually, as I'll get to in a second here, that Babylon native compilation will compile down to those two different frameworks, respectively. One of the things that really came in an advantage for me when I was performing this, working on this hackathon and putting together a Babylon application with a very short time frame, was Babylon's built-in tooling. So they have what's called a scene inspector. I'll go ahead and I'll bring up an image of that here: a scene explorer and a inspector. And so what this actually lets you do is, right in your browser, as you're developing your Babylon application, you get a explorer view of every node, every granular, all those granular components. You can see them right into your explorer. You can highlight over them, similar to how a web developer or front-end developer might use like a Chrome inspector on a web page to see all their different HTML elements. You have that same functionality here, but in the 3D space. The inspector allows you to actually take those elements and manipulate them. You can apply positional transformations, rotational transformations. You can give them unique names, change their material. You can even do some more advanced features, such as turning on or off collisions, adding some additional vertex normals. And these things were invaluable to me in my early development with BabylonJS, putting together this 3D space and making sure that once someone came in on the virtual experience, they were going to have a good time. Babylon native is Babylon's ability to write your code once and deploy it anywhere on across any platform. So if you have a virtual experience in your web browser and you want your clients to be able to access that same experience, whether they're coming in from an iOS app or an Android app, you can do so, similar to something, say, like React Native, where you write your code once and deploy it to multiple environments. Babylon has that same functionality where it will compile down to, as mentioned before, Apple Metal, or in the case of like Android or Microsoft, DirectX or Vulkan. Similar to the built-in tooling, Babylon being an open source framework, has extensive community and forum support. I had a number of questions while working on my project in Babylon, and found that if my question was not already asked and answered on the forums, I could go there, post it, and I got an answer, honestly, within that same day. So there is a strong sort of sense of developer community when working with this framework, that sort of is reminiscent of many other open source projects, or projects that started off as open source and kind of eventually became something larger. Additionally, there's like this Babylon playground, where on their actual website, you can go in and you are given essentially a 3D scene that you can, as the name implies, play around with. You can, add objects, write code directly into it, and kind of see immediate feedback on what that looks like. And those playground links can be shared. So oftentimes what the community will do in these forum posts or in these these message boards is, if someone has a question or a problem, they can provide their own or share their own playground for it, or someone coming in to answer that question can share a playground link as well that shows that implementation. Very, very similar to something like a Stack Overflow, but with 3D application development. One of the final points here that I found to be a sort of a strong candidate for why I chose to run with Babylon for my hackathon project was that it is actually backed by Microsoft. Microsoft has put an extensive amount of funding into developing this framework, especially over the past year or two. So what started off as a, clearly, open source, not too many developers working on it, library has grown almost exponentially, I'd say, in that time, as they've received additional funding to further develop some of these application features, and have had that sort of direct link to the developers over at Microsoft with regards to how to implement things like DirectX and Vulkan. So said a lot of things just now. Let's go ahead and take a look at what some of this code might look like. So this is a fairly standard, or a fairly bare bones rather, HTML file up here. The only thing on here is just a canvas element with ID render canvas. So in our Babylon code here, the very first statement here is just grabbing that canvas element via get element by ID call. Then you create a Babylon engine using babylon.engine, which accepts a canvas element as its first argument. From that engine, you can then create a scene. If you wanted to have multiple scenes, you could create multiple scenes. But in this case, we're doing something simple. So we're just going to have a singular scene here, and we're going to give that scene a color using the babylon.color3 method, which just accepts RGB value from 0 to 1. Our scene is going to need a camera. So we'll create a new Babylon free camera here and give it a vector, which is just another word for an angle that camera is looking or pointing down at. And we'll add some lighting to the scene using the Babylon point light to create a light on that same sort of vector there. Now, for the purposes of this example, it's just going to create three fairly, simple objects here: a box, a torus or a donut, and a cylinder. Now, whenever you create a mesh in a 3D application, the first, I keep saying this word mesh, essentially think of that like a skeleton. It's essentially a set of points in a virtual space that represent that object. So in this case here, we're creating a Babylon mesh box with name, our ID box, giving it a default size of 2 units. And we're saying that we want to create that box on our scene. Now, we're giving the X and the Y coordinates a slight rotation so that that box, when we look at it, rather than just being a square, will actually be kind of canted in a diagonal so that you can see some of the different faces of the box. Now, we need to give our mesh a material so that it has essentially a color. So we do that with Babylon standard material, giving it a ID of just material. Again, applying it to our scene. We'll give that material a color, again, using the same color3 method. This is roughly going to be a tealish bluish color. And we bind that material to our box through the box.material property. Now, I'll kind of, won't go into as much detail for these next 4 little chunks of code here, but essentially it's the same step of creating our other 2 objects, a torus and a cylinder. So you create the mesh, you give that mesh a position or a rotation, and then you just apply material to it such that it has essentially skin to your mesh's skeleton. Finally, we'll go here and we'll instantiate a variable t as our representation of essentially time, and we'll run this. We'll have this function called render loop. Now, what this render loop function is going to do is going to render our scene. It is going to decrement that time variable by 1/100th. And then while the scene is rendering, we're going to rotate the box on the y-axis. We're going to scale the torus on the z-axis, and we're going to move the cylinder on the y-axis. Finally, we take our render loop function and we pass it into this engine.runRenderLoop method, which essentially accepts a function of what you want to be running in your Babylon scene's rendering loop or your engine's render loop. And executing all this code, we'd get the following scene here. So as we can see, our torus is scaling its z-axis, our box is rotating along the y-axis, and our cylinder is moving up and down along the y-axis. And this would be just exactly what you would see running it directly in your browser. So let's share a few useful links here. This right here is a JS fiddle that actually goes straight back to the example that I just showed. If you wanted to mess around with it on your own time, kind of apply some different things and see what you can do, see if you may even be able to add your own extra box there if you wanted. I have a link here to the Web GPU standard. It kind of goes into a much more detail on what exactly Web GPU is and what it seeks to accomplish. Standard link here to the BabylonJS homepage. They have a ton of links on there and a ton of examples. It is a phenomenal resource. The BabylonJS documentation. If you plan on developing with Babylon, I highly recommend taking a look at the documentation. They have a number of demos. They have a number of, sort of personal, like sort of small little projects you can do. As mentioned before, they have multiple links to their, Babylon playground where you can see a lot of their examples and code running on your machine. And finally, I included in here a blog post that I found, fairly informative. 3JS I mentioned here. I didn't talk about it much because I didn't want to take up too much time. 3JS is another very popular web rendering library that was for a long time, I think, the de facto standard for creating and rendering 3D content in a web browser. Babylon has kind of come in to sort of disrupt that hold on the market. And this blog post here is a very good sort of breakdown of some of the advantages of that Babylon offers over 3JS, in a more modern kind of, web browser landscape. So with that, I'd love to open up to any questions that we have from anyone on the live stream or here in the Zoom call.
Hey, Myles. I have a question.
Yep, sure thing.
So I know you said that this can actually compile down to native Android and iOS, but what about trying to use it just for a single screen in an existing app? Like if we wanted to have some page where we could just like render and rotate something, but embed it into an existing application, is that just as simple as like a web view because it's JavaScript?
Yeah, honestly, yeah, because it's JavaScript, because it runs in the browser, you could do just a web view. Alternatively, you could drop like an iframe if you wanted to. That essentially your browser-based view is still going to have, any, like if you don't want to compile this down to like the app level, just rendering it in a browser running on a phone, so long as the browser version that they're running is, modern enough that it supports these things. And they actually do, there is, if you kind of dive a little deeper into the documentation, there are examples of, how to provide browser fallbacks for, certain older browsers if you do need to support them. But yes, actually, it would run the same experience just in the phone browser. It's a little bit weird because, touch controls are a little different, obviously, than, mouse and keyboard controls. So depending on how you actually code it out, when you're writing your application, you can handle that. But yes, it would be able to run via a web view or like an iframe.
Okay, I think that the web view one is more kind of aimed at my question, like not going to a browser, but being able to have like a certain tab in an existing native app, have like a 3D view there.
I haven't personally tried that, but yeah, I don't see why you'd run into any issues with it so long as the web view. I mean, my understanding, I'm not by any means, I'm not a mobile development expert. My understanding of web views, though, within mobile frameworks is that they are essentially they're using the phone's browser application and just rendering it directly in your app. So long as your web view has access to essentially the same browser methods that you would find if you were running something directly in the browser, I don't see why this would be, I don't see why you'd run into any issues there. But that is something that's definitely worth taking back and looking into, and just kind of seeing maybe if they actually have on one of those forum pages or in their documentation somewhere a recommendation on how you would go about implementing that.
Cool. Thank you.
Thank you for the awesome question. And I think Ted, I saw you were trying to get something in there as well.
Yeah, so I was gonna ask actually if it's mobile ready, but you've already answered that. So and looking around their site, I see that, and I had been wondering also some good use cases outside of games, and then one thing I think about is like apartments or housing, especially when you're if you put together a design studio with like if you're a builder. you might want to help someone pick out like their furnishings in their house that you're building for them, right? Like where to place things and all. And
Yeah.
actually looking around the website, it looks like they're doing that, or they show an example of some of that, but that looks really exciting. So I'm kind of curious if anybody's going to marry this with like AutoCAD or anything like that. But
Yeah, so I mean, I believe that's similar to like how Lowe's, I believe, had that what their implementation of Babylon was that, you similar to like what you said, a essentially design studio where you could go in and sort of, if you have like a project in mind, you want to remodel your kitchen, remodel a room or whatever, you can actually go and in that virtual space, put the cabinets together, the furnishings together, put all that stuff in there and see what that actually looks like in a rendered environment. But yeah, I actually, it's funny you mentioned AutoCAD. I think one of my college senior year capstone project was a augmented reality AutoCAD application on mobile. So it's funny that you had the same idea, because we essentially took, at the time it was OpenGL, because I don't know if this was around back then, but we essentially used the OpenGL library to have a phone app, an Android app, that you could scan a QR code on if you think like an AutoCAD printout, right? And then what that QR code scan would do is display that CAD model in augmented reality in your phone. So you could actually sit there and you could move the phone around the sheet of paper and you'd see the different angles of that CAD model. You could spin it, kind of blow it up, shrink it down, take different parts apart on it. And that was all using OpenGL. So, I mean, that technology has only come farther since 10 years ago. So I would be hard pressed to think that there isn't someone with that same idea, trying to bring that to market right now.
Yeah, sure thing. And I mean, this also makes me think, there are a number of sites that would normally go build a web or a mobile app that they might be able to do like a truly mobile friendly website that would give kind of a good visual effect both on a standard browser and on a mobile browser without having to go invest in two different pieces. So for again, kind of an apartment complex is a good idea, right? If you wanted to show like a 3D, like looking around in our models and our things, more so than just the standard pictures, that this might be a good,
Absolutely.
for any place where you're like, hey, I don't want to install a whole app, for this because, I'm going to use it for like a month and then get rid of it, right?
Absolutely. Yeah. And I mean, if you think about it, calling back to your apartment idea, offering like a, virtual tour of your apartment complex or of what, this model looks like versus that model looks like, and actually having someone, not a virtual tour of somebody who's just, holding a phone and recording a video while they walk through an apartment, but actually, someone that you can actually, virtual space, move through and move around and interact with would be phenomenal.
So, I mean, your code example looked pretty easy. I mean, have you been able to play with it much at all, or is it like how difficult did you find it to work with, or
yeah? So yeah, like mentioned, myself and my team for this hackathon last year, we had 24 hours essentially to put together a application for this hackathon, and in those 24 hours, we were able to essentially build out. We didn't have to build the virtual space. That was provided to us from a past project, but we built in all of the movement rigging, camera rigging, lighting, interactions, all the keyboard inputs, all the things that would like modify the scene per se, in that 24-hour space, having zero experience with this framework prior to it. And we actually won the hackathon with that submission out of about 1,800, I believe, applicant or entries. 180 teams, 1,800 developers. Our project was selected as the winner of that hackathon just because they had never seen anything like it. So I would say stick a whole team on there, give them an actual, feature length amount of time or epic amount of time to really get, ingrained with this library. I think the possibilities are, huge for what you could do with it. I mean, I'll go back to I'll see if I can't go back to that previous slide again. I don't know. There we go. I mean, this Space Pirates demo, the Space Pirates application is coded entirely in Babylon. And I've actually, I've actually messed around with it a little bit. I'll post it in our Slack later. But it's pretty feature complete. And that's, like I said, entirely running in the browser, entirely web-based, JavaScript. So, I think there's a lot you can do with it.
Oh, well, it's really nice. Thank you for the presentation. It's really good.
Absolutely. Thank you for the great questions.
Really informative talk, Myles. Really, really nice job. Reminder to you all, we do these talks every Thursday, 5:15 p.m. Eastern time. And next week, it's going to be Sid Akula, who is a senior software engineer with us. He's going to give us an overview of GraphQL with Java. As a lot of you know, GraphQL is a query language for APIs, which gives client the power to ask for exactly what they need, and it makes it easier to evolve APIs over time. So I'm looking forward to hear about the best practices on using GraphQL with Java. Make sure you all mark your calendar for next week, and thank you all once again for joining. Have a wonderful evening, and I'll see you guys next week.
Thank you, Parag. Thanks everyone for tuning in.